Welcome to the channel, everybody. This is Programming Explained Simply. This is going to be a video series about getting started with PLCs. It's intended for somebody who knows very little about PLCs, so we're just going to start from the ground up and not make any assumptions on what you may or may not already know. I am a controls engineer, and I've been working almost on a daily basis with PLCs for the past 17 years. So I feel like I'm qualified to create this video and share it with you guys. I'm going to apologize in advance for the poor handwriting, but this is just kind of how I like to teach. So the first question is, what is a PLC? And this is my definition, but I tell people that it's a specialized computer for controlling machinery, right? It's made for industrial environments, but basically what it does is provides a way of automating machinery. We're going to talk about some key terms to know, and then we'll talk about kind of how a PLC works. We're going to I'm not going to be specific about any brand of PLC. We're going to keep the videos generic and the discussions generic, because they all pretty much do the same thing. They solve the same types of problems, provide the same type of control. Once you learn one, it's not that difficult to switch between brands. So we're going to try to keep it generic. First three terms that we're going to discuss: inputs, outputs, and then internal memory. We're going to use a lot of that once we start programming. So let's talk about first inputs and outputs. This is going to be my PLC here. I'm going to divide it up into a couple of parts. Over here we're going to have a power supply, followed by a CPU, which is our processor. This is what actually executes our logic. We have inputs, and there's our outputs. Input and output is something that you can touch, okay? I'm going to draw an arrow going into the PLC and one coming out of the PLC, because that's what happens to each one of these. So everything that we're going to write on inputs and outputs has a physical connection to the PLC. So this input typically going to be some type of sensor. Maybe it's something simple like a button or a switch. It could be some type of photo cell. It could be some type of pressure switch. Maybe some type of temperature sensor. All different kinds. Just an endless array of different types of sensors that can be fed into a PLC. Coming out of the PLC is going to be things that it controls. So some easy ones: a horn, a light. You see a lot of those if you go into a factory, lots of horns and lights. Maybe a valve, some type of pneumatic or hydraulic valve. An electrical relay, which might in turn control a pump, maybe a motor, anything like that. But the main thing to know about an input and an output is that it has some type of physical connection back to the PLC, and these are typically devices that you can touch, okay? From there, the next thing that you can't touch: internal memory. Right, can't touch it, just inside the PLC. That's pretty much all you need to know about it. If it doesn't make sense, and once we get a little bit further into the video, it should start to come together, okay? One thing that inputs, outputs, and internal memory all share that you have to know about is addressing, okay? So whenever you physically connect a wire to a PLC, you have to have some way of programming that when that wire comes on or off, some way of representing that inside the program, okay? And that's where your address comes in. So if this is our PLC card, it doesn't matter if it's an input or output. We'll just say it's an input for now. These are supposed to be Phillips head screws, by the way. So we'll say this card is capable of accepting 4 inputs, okay? So we land our wire on this, and this goes to some switch, some type of button, okay? So when you press the button, power goes to that terminal. The PLC can see it, right? But how do you use that inside the program? How do you reference that, you know? And that's where the address comes in. So every screw on this card is going to have an address to represent it. Different brand PLCs are going to have different addressing schemes, but since this is an input, let's say this is I1, and this one is I2, I3, I4, right? So the letter I designates inputs, and then each screw has a unique number, right? 1 through 4. Same thing if we had output card, try to fit 4 in there. We got a wire going to a red light, okay? That's an R. Red light. Output card. Let's do O for output. So we got O1, O2, O3, O4. So the O is the designation for an output, and then each terminal on our PLC, these screws are on these cards from the last pictures, okay? Each screw has a unique number that represents it. So if power comes on this wire to this screw, then in the program, I'm sorry, I said that backwards. In the program, if output 1 comes on, then power is going to go from this screw out to the device, okay? So it's exactly the opposite of the input. Input receives power flow, output controls the power flow. It sends the power flow out to the device. When we're talking about internal memory, again, different brands use different letters. For us, for our discussion, let's say the letter M. So we can have, let me write that down. Internal memory is M, so we can have M1, M2, M3, and so on and so forth, right? So anything, when you program, everything that you program is going to have an address of some type, okay? So for now we'll use I's, O's, and M's. One other one that we're going to throw in there right quick, this is still internal memory. It's for storing numbers. M's in this case are Boolean. For our discussion purposes, these are all Boolean, okay? On or off. That's it. If we want to store a number, we're going to put it in something called a register. And a register is just a container for holding numbers, okay? So we use the letter R. So we'll do R1, R2, R3, right? Same scheme. So just to recap, we got I's, O's, M's, R's. Inputs, outputs, memory, Boolean memory, and R's are numbers that are internal memory as well, right? But it's not Boolean. Boolean, so we'll just say it's an integer. Above the line here, inputs and outputs, you can touch them. Below the line, internal memory, can't touch. Just resides inside the PLC. Alright. PLCs can have different types of programs in them. The one you're probably most familiar with, and the one that we'll be discussing, is ladder logic. But that's not the only thing they can do. They can also do some other things, maybe function blocks or structured text. But this is the one that we're going to focus on because it's the most common that I've seen, and it's really a great place to start. So it's kind of graphical. You don't have to like worry about the syntax or anything like that. And it's easy to read a simple program, and it's easy to write a simple program with that. So let's start talking about ladder logic. You might say, why is it called ladder logic? And the reason is because when you draw it, it looks like a ladder. So these two vertical bars here, if you say that they're the sides of the ladder, and this line across here is actually called a rung, just like a rung of a ladder. Just going to draw a couple things here. So we got 3 rungs, right? When you read ladder logic, and the way it works is it goes top to bottom, it goes left to right. Okay, just like reading a book in English. Top to bottom, left to right. And these are some different components of the program that are very common. These on the left are, let me write it over here, we can read. Contacts on the left, on the right. These are coils. So contacts and coils is where we're going to start. Alright, so now that we know a little bit more about the PLC, let's talk about kind of what the processor does. I'm going to break it down to 3 things. One is read inputs. 2 is solve logic. 3 is update outputs. Okay, and it does it in a loop. What I mean by loop is it just repeats itself. Okay, so it's going to go step 1, step 2, step 3, and when it gets back to step 1, it's going to do the whole thing over again. So one loop is known as one scan. Okay, so one scan of the PLC does all 3 of these steps, and different manufacturer, different brand PLCs can scan slightly different, but this is a great simplified way. It's easy to understand, and it's good for you to wrap your head around this concept of what's going on before you go any further. And like the different small differences between the other different brand PLCs are not a big deal. Once you get to programming them, you can learn what those differences are. But let's talk about what I mean by read inputs. So those Phillips head screws that we talked about earlier, we need to go check and see which one of those Phillips head screws have power on them or not. So is anybody pressing any buttons, or has somebody let off the button that they were pressing on the last scan? So let's go check all the inputs, see if they have power on them or not. Wherever those inputs are used in the program, we need to update that and solve the logic. And then remember that what the PLC does is controls things. So once the logic is solved, then it needs to go update the outputs, because when it solved the logic, some of those outputs may have changed states. So like if we were cutting the light on, maybe it needs to be off now, or if it was off, maybe it needs to be back turned on. But update outputs is going to go put the power on those Phillips head screws so it can control those end devices that we talked about earlier. That is a very simplified scan, but that's to me, that's a great way of understanding what's going on. Alright, now let's go over a simple example of ladder logic. This example is going to be press a button, light turns on. Right, we're going to be consistent with what we were talking about earlier. So we draw that out. We've got our contact, we've got our coil. But right now they don't represent anything. They need to be given addresses. So let's say our button is input 1 and our light, that's a O for output, output 1. The button is given that address because of the terminal that the wire was physically landed on. Okay? Same thing, the light was wired up to the Phillips head screw that is represented by O1. So when we program it, this contact is I1, this coil is O1. When nobody's pressing the button, the logic is trying to flow this way. Remember, we go top to bottom, left to right. So it's trying. It's coming down here, cutting across this rung, hits this normally open contact, and if nobody's pressing the button, then the logic stops flowing right there. Now we're sitting there scanning, we're doing our loop, our scan, reading the inputs every time around. When somebody presses that button, when we come around that scan again and we read inputs, it's going to see that terminal has power on it, and it's going to update in the program everywhere that I1 is used. It's going to cut it on. When it gets to step 2, it's going to say, oh, I1's on, let me go ahead and let the logic flow, right? And it's going to say the output O1 needs to be turned on. Step 3 is actually update the outputs, which means turn power on the O1 terminal. So just simple as it can get. One contact, one coil, you press the button, the light comes on. That's a great simple demonstration of addresses in use. And we didn't use internal memory on this one, so let's go to the next. Let's do another one on a different sheet of paper and we'll demonstrate internal memory. Alright, so in this one example, we're going to do the same program that we've been doing, but we're going to use internal memory just to demonstrate how it's used. So buttons pressed, light turns on, and our addresses button, we're going to keep it I1. Our light's going to still be O1, and our memory, I'm just going to use M1, but it could be M50 or M3000 or whatever we wanted it to be. It doesn't matter, just a unique M number to use. And programming's like anything else. You can write a program many different ways that all end up doing the same thing. So in the last one we had our input 1 turning on output 1, and this one we're going to have input 1 up here and output 1 down here on separate rungs, okay? And we're going to use internal memory to connect the two. So what you notice is we have a coil with the address M1 and a contact with the address M1. And because they both share the M1 address, they are connected. They are the same thing. So when the logic's flowing, right, it's coming down, hits the contact. If nobody's pressing the button, the logic cannot pass. So it comes on down to this rung, hits this M1 contact. If it's off, it'll just keep on going. If there's more logic down below, it'll keep trying to solve it. If not, it'll come back to the top and start again. So whenever the scan comes around that somebody presses the button, you'll see input 1 has power on it, so it'll update this input, and the logic will be able to flow. And it'll see M1, the coil can come on. Like I said, because when this M1 comes on, that means this M1 comes on. So when it hits this rung, the logic can pass that contact and it can cut on our output, which is our light. So the same program as a while ago, we just programmed it differently, and we used the internal memory. And this is, you might be saying, why would you want to do this? And I know this is kind of a bad example of the need for internal memory. I just wanted to demonstrate how it works and keep the scenarios simple. What you'll see is once you start programming a little more complicated programs, that you can't do it with just inputs and outputs, that you have to use internal memory just for the program to work. So I think that's a good stopping point for us right now. Alright guys, so that's the end of the video today. Thank you for watching. We tried to keep it high level and just focus on the basics. There's a lot more information that we could have talked about. It's, still fundamental type PLC information, but I didn't want to have information overload. So check out the next video. We're going to actually do some programming in a simulator. And if you have any questions or comments, add them below. Subscribe if you like the channel. That way you'll see the next videos coming out. So thank you and bye.